Before we begin today's lesson, I need to establish a kind of relationship and get you to sort of buy into it. If you don't believe this is true, then it's going to be hard for me to convince you. Now, for this to make sense, I'm going to bring back a lot of the stuff from previous lessons, so hopefully you've been following along. Even if you're not, give it a chance. Come at it with an open mind, right? Here's my first relationship. Notice the four different triangles that I've drawn. One of them, of course, has a dotted line. Theta has a corresponding length. That's a dotted line. This theta has a corresponding length. This theta, corresponding length. This theta, corresponding length. Each of these arms are the same length. I arbitrarily chose the number 2. Everyone with me so far? What do you notice about the dotted line as the angle begins to increase? Yes?
Like the side of the length of the line, like the dotted line increases too.
Right. So, can we agree that in any triangle, I just drew 4 random ones, if the angle increases, we can state that the dotted line will also increase in length. So far, so good? Okay, so I'm going to write that down. So, as theta increases, the corresponding side length also increases.
Are we going to get a sheet with this on?
Yeah.
Or?
Well, you can write this down because you're not going to get a sheet of like all the activities that we do, but I will provide you with a summary. All right? So I'm going to extend that further, and this is going to involve fractions, and now some of you are already cringing, but think about it this way. So let's pretend I have a fraction. Let's pretend I took the angle and I took the side and I turned it into a ratio. And it just so happens that this was a 1. Just because a 1 is an easy number. Okay? So, for example, let's pretend sine A is 0.8 and the length happened to be 0.8. That's why I get a ratio of 1. If this became 0.9, in other words, it increased, but the ratio still needs to be a 1. What can you tell me about the denominator? What can you tell me about the side length? It has to go up. Just like how we said, if the angle goes up, the side length goes up. For this ratio, if the numerator will go up, the denominator will also go up. It will have to also increase. I just want you to notice that there's a pattern between this, or a relationship between these two. Okay? Did I lose anyone? No? So far you're still like, okay, what are you getting at? What's the point? Okay. Ready? To introduce the new law or new idea that allows us to apply trigonometry to non-regular triangles, I'm going to have to bring back that challenge question. Remember a couple of lessons ago when we were preparing for the test, I gave you that challenge question where there was thing 1 and Jess and someone else and they had a little thing with a balloon. Okay? I'm going to bring that back. Challenge question. Recall, it was something like this. So this was, let's say, angle A, B, C. This was 100. And we just happen to call this, let's say, x. And therefore, that length would be 100 minus x, right on. Now, also recall, how did we link these two triangles together? We took a smaller triangle and we did something like tangent of angle A is equal to opposite, sorry, actually let's do height. Okay, the height over x, while we did tangent of angle B was opposite over that. Okay, you don't have to copy this down, but I'm just recapping the question that we've done together. And then I've noticed that, hey, if I were to isolate for the height, and I were to isolate for the height, these two equations are equal to each other. Ringing a bell? You don't have to solve it, but I need you to remember that we've done this together. So x tan theta is equal to 100 minus x tan b. Just call it theta, a and b. Okay? Somewhere along the line, we need to ask ourselves a what if question. We use tangent to associate two triangles together. What if we give me a what if question. We use tangent to associate these two triangles. Is it possible to, what if we did
Sine.
what if we use sine? What if we use cosine? So let's start with sine just because SOH CAH TOA starts with sine. Okay? What if we use sine to associate these two triangles? Ready? So here it is. I have one triangle that's A. Oh, I forgot. This is little a and that's little b and this is little c, isn't it? Triangle A with my height. This is my b. And here is angle B with little a with my height. Ready? We're using sine. Sine of angle A is equal to opposite over hypotenuse. Sine of angle B is equal to opposite over hypotenuse. And it's the same thing. Let's isolate for the height. This would be B times sine A equals height, and A times sine B equals height. And if I were to put this together, B times sine A equals A times sine B.
Yes.
Interesting. Now we can stop there, but using some algebra, anyone ring up, does it strike a light bulb? Can you rearrange this equation a little bit to make it look cleaner, to make it look nicer, to make it more memorizable, so to speak? Because obviously there's a pattern, BA, AB. We can change it up a little bit to make it easier to absorb.
Well, if you divide both sides by b, then you'll get a sine b over b.
Sorry, so divide both sides by b, so this will this will turn into 1. So we have sine of capital A equals A sine B divided by b.
Yeah.
And
And
then
then you could divide both sides by little a,
little a, so you get capital A divided by
small
A equals?
sine b over b.
That's really nice. So it happens all the time? Did we stumble on something? And this is where what if questions take us. Okay? Did we stumble on a relationship that happens every single time? And that's worth thinking about. Just as how the challenge question got us to solve problems where we normally couldn't. Okay? Using a different ratio, we might have discovered something novel, something new here. And it didn't require some mathematical genius, just a curiosity that got us there.